Perseverance was sent to Jezero crater because of clear evidence that it hosted a lake billions of years ago. But the rocks it's exploring now don't look like lake deposits.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars.
The delta deposit in Jezero crater shows that a sediment-rich river flowed into a lake early in Mars history. This scenario is even clearer now thanks to views of a mesa named Kodiak, an eroded remnant of the delta observed by Perseverance. It's now exploring terrain dubbed Sita that likely was covered by delta deposits based on the presence of other delta remnants that show its former extent. Here's the view from the current location, with Kodiak Mesa about 1.9 kilometers or 1.2 miles away, closer than at the start of the mission. Perseverance routinely monitors for dust devils, and it caught a huge one swirling toward Kodiak. The SuperCam telescope observed Kodiak from this location. It shot this mosaic of images at about 8 in the morning to get sunlit cliff faces, which become shadowed later in the day. The circular SuperCam images mosaiced together create the caterpillar effect. The layers are even better exposed in this new mosaic. Here's Mars Sky for scale. As I've described in previous episodes, the combination of flat and sloping layers provides unequivocal evidence of a delta deposit. This is pretty much a textbook example. There's evidence of fluctuating lake levels based on the way the flat layers cut across the sloping ones, showing erosion when the lake was lower. The rounded cobbles and boulders show that sometimes the water flow was strong enough to carry larger and heavier materials than sand and gravel. It's the flat-lying bottom set beds that likely would have extended out to where Perseverance is now. So it's reasonable to think that the outcrops with flat surfaces and what look like layers could be lake deposits. Perseverance has started an investigation on one of these outcrops with a rock hammer for scale and as an homage to geologists. But a look at the rock's texture is needed to confirm whether these are lake deposits. Perseverance uses its abrading bit like a geologist would use a rock hammer to get past the weathered surface to see the interior textures. After the abrading operation, the turret swings around so that the gas dust removal tool can blow away the powder, just like a geologist would do on a dusty rock. And here's what that looks like. All the light-colored stuff is fine powder produced from the grind, but there are coarse bits too. There's clear evidence for the coating that I described in episode 25, which appears as a patchy covering on many rocks observed by Perseverance throughout the mission. This shows how important it is to grind through this coating to expose interior textures. Like the 3 previous grind spots elsewhere on Perseverance's route, this one is pretty colorful for a rock, and the texture is similar to those 3 previous ones, with a mix of very angular grains and others with irregular curving shapes. There are no obvious rounded grains like the ones produced from flowing water. In fact, there are grains so angular that it's highly unlikely they were transported by water, which has a rounding effect. Thanks to the Curiosity rover in Gale Crater, which also held an ancient lake, we know what Martian lake deposits look like. Here's an example of a mudstone, a name that is conveniently self-explanatory. And here's a conglomerate of sand and pebbles that forms from the sediments in fast-flowing water. These rock textures look nothing like what Perseverance is seeing, which instead looks a lot like the texture of rocks produced from explosive volcanic ash deposits. This sample is a welded ignimbrite from California. Based on the clear evidence for a delta deposit in Jezero, it's probably safe to conclude that any lake deposits that covered this location have long since eroded away. They probably formed rocks that were easily eroded, which is consistent with the heavily eroded delta remnants visible today.